Good morning, students. Can you hear me? Can you see the screen? Hello? Brandon, can you hear me? Can you see the screen? Just checking. You said something? I'm not hearing anything. You said something, Brandon? Jabba, you can hear me? See the screen?
Yes, sir.
Yes, sir.
All right, good. Thanks. All right, guys. So we're gonna practice some transformation today, and we're gonna go straight to past papers. All right. So we're gonna do some January past papers. If based on what time we finish, I might touch on the classwork that we did. All right, so let's get straight into it. The session is being recorded, so persons who are not here, they will, they will have the opportunity to watch the recording, and then you guys who are here, I advise you to go and redo these questions, and you can use the video to help. All right, so let's look at this January 2024. This was last year, January 2024. Paper 2. This is number 3. So you can get a transformation in section 1, and you can get a transformation in section 2. So section 1 transformation will always sort of look like this. We'll give you a graph, and you have to draw some transformations on the graph, or you have to read some transformations from the graph. In section 2, the transformation is normally the calculation type where you're using the matrices. Alright, so let's look at this one. They said the diagram below shows 3 triangles, P, Q, and R. 3 triangles. Triangle P and R are images, triangle Q and R are images of triangle P. So this is the original triangle P, and there's a transformation to this and a transformation to that. Or it could be that you go to this first and then that. Let's read and see what they said. Right? Oh, they said they are images of P and Q. So, alright, so there's a transformation from this to this and from this to this, based on what they have said so far. Let's see. It says, describe fully the transformation that maps P to R. So a transformation takes us from this one to this one. That's what they're asking us. And you can use a process of elimination. Now this looks like a translation. Because translation is the one where there's no change except in position. So it's like this triangle moved to here. It did not turn. There's no rotation. There's no change in orientation. There's no change in size. Just a movement from one location to another on the graph. And so I would say it's a translation transformation. But you cannot just say it's a translation. You have to give the components of the translation. That's from P to R. Now. P to R is a translation. You cannot just say it's a translation and that's enough. Question says fully. And how you describe a transformation fully is to give the name and the components, the measures of the transformation. So the name is translation, and you need to get the components of the translation. The components of the translation is how many units left or right and how many units up or down. And what you can do is use 1 point. Don't try to count it off. Use 1 point. So for example, I'm using this point. So I'm going to look how many units to the right. This one moved. And it is moving to here. That's the corresponding point. So I'm going to count how many units left or right. In this case, it is to the right. See it here. Let me use a red ink to show the movement. It is this number of units to the right. And that's 2 units. Because from 2 to 4, that's 2 units. So it's 2 units to the right, and then this number of units upwards to here. And then again, 1 unit, 1 grid is 1 unit, right? That's a scale. So that is 1, 2, 3, 4 units upwards. 4 units upwards. So it's 2 to the right and 4 up. So the horizontal movement in this translation is 2 to the right and 4 upwards. 2 to the right and 4 upwards. And when the translation is 2 to the right, 4 upwards, it can be represented as a translation matrix 2, 4. So you can say 2 to the right, 4 upwards, or you can represent it with that matrix 2, 4. Let's go and describe it now. So the translation, 2 units to the right and 4 upwards. And we only needed to use 1 point to see what it did. You don't have to do the entire triangle all at once. So let's write it here now. So we're going to say it's a translation two units to the right and 4 units upwards. And we can say given by 2, 4. That's the translation matrix 2, 4. So I've given the name of the transformation, which is translation, and the 2 components. 2 units to the right and 4 units upwards. Translation has 2 components. How many units left or right and how many units up or down. What go with that? What okay? With that one?
Yes, sir. Yes, sir.
Alright, so here now we're going from R to Q, not from P to Q now, we're going from R to Q. So now we're going from this one to this one. Look carefully. Let me erase these. We're going to go from R to Q now. Let me take these off. So I want to see now how we go from this one to that one. Now, it's not an enlargement because there's no change in size, and this is not a translation because this and this are not exact shape. Right? So it is either a reflection or a rotation. Either a reflection or a rotation. Right? Now how we can eliminate which one it is to remember that reflection in a line. And what's a reflection? I mean reflection in a line. Reflection in a line reverses orientation. So oftentimes a rotation and a reflection might look alike. To make this distinction, you can check the orientation. So let's put some points on this and a corresponding points on this. So I'm using this point as A, put this point up here as B, put this point as C. So I've given this an orientation of anticlockwise. A to B to C is anticlockwise. The corresponding points over here will be, this one will be A prime. The one at the top here will be B prime. And the one down here will be C prime. And if we go A, B, C, this one is going this way, clockwise. So the orientation is reversed. So once the orientation is reversed, we know that we have a reflection in a line reflection. Reflection in a line is the only transformation that reverses orientation. And to describe a reflection, we need to state what the mirror line is. You cannot just say it's a reflection. You have to say what the mirror line is. And the mirror line is going to be halfway between the image and the object. So for example, the halfway between these 2 points is right here. And halfway between these 2 points is also right here. So that vertical line becomes your mirror for this reflection. That's a vertical line passing through 1 on the x-axis. So this line is x equals 1. So it's a reflection in the line x equals 1. Simple as that. Right? And that's how you describe a reflection. You give the mirror line, and the component of a reflection is the mirror line. Just state what the mirror line is. The mirror line is x equals 1. So this transformation is a reflection in the line x equals 1. That is it. And that's the description. Everybody okay with that one? Everybody good? Okay, there's
Yes,
a class
sir.
and you have to respond.
Yes, sir.
You have
Yes,
to
sir.
respond. Answer. Come on, man. Alright, so I finished this discussion. There was no other paper on this one, right? So as simple as that, we are done with this paper. Alright, so this is a really straightforward and easy question. I think we might need to do the classwork one too. to practice the compound transformation. All right, let's look at now 2023. Let's look at 2023 now. Let's look at 2023. So January 2023. All right, I think this one has a nice question on it that I need you to all remember. Pay attention to. So 2023 is a question in section 1. Remember 2023 I had this question on it. It really messed up a lot of people. But easy, you know, this is it. This is the transformation 2023. Let's see what it says. It says the diagram shows three quadrilaterals P, Q, and R. This is P, this is Q, that is R. All right? And it says Q and R are images of P after two different transformations. Two different transformations. So this has a transformation to this, and this has a transformation to that. All right? And they're going to want us clearly to describe those two transformations. Well, let's answer the questions. First part says, on the same grid on page 9, draw the image of quadrilateral P after a translation of 10 negative 4 and label it P prime. 10 negative 4. So they're asking us to do some transformations first before they ask us to describe the transformations from P to Q and from P to R. Alright? So this translation is 10 units to the right and 4 units downwards. That's negative 4. That's what it means. So we're going to move each point 10 units to the right and 4 units down. And because it is a translation, what we can do is move 1 point and draw back the same shape around that 1 point. Because translation does move the object from 1 point to another, but we tend to try to do the transformation 1 point at a time. So doing a translation on this, 10 negative 4, which is 10 to the right, 4 units down. So let's count it off. Let's say we're using this point to do the count off, and then we're going to draw back the same shape around that point. Let's say we do that. So we're using this point. You need 10 units to the right. With your mind, please. Alright. So moving this point 10 units to the right and 4 down. So let's count the grid. Yes, the grid here is 1 unit. I have to make sure. And the grid here is also 1 unit. Alright. So each grid is a unit. So 10 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can check it off. This is negative 7. From negative 7, if I add 10 to negative 7, you're going all the way over to 3. So that is correct. Alright? And then that's a 10 to the right. Then we need 4 down. 1, 2, 3, 4 down. Which is right here. So this point is coming right here. Alright? And I'm going to use the blue now and draw about the same shape that this is. So I'm going to put this diagonal piece here first, which is 1 right, 2 up. 1 right, 2 up. And this diagonal piece is 1 left, 2 up. That's this diagonal piece. And then we have this little shorter diagonal piece just in that square right here. And we have this other piece right here. So that is the shape. Maybe I should have used this point over to this top point. Let's do it. Let's take out the red and use the top point. So this construction is not in the middle of the diagram. Let's do it this way. Alright. So maybe I should have used this point. With the same thing, it don't really matter. If I was using this point, it's the same thing. 10 to the right. And then 4 down. 1, 2, 3, 4 to here. That's 10 to the right. And then negative 4. And then supposed to label this P prime. label it P prime. So this is P prime. But okay with that? But good?
Yes, sir. Yes, sir.
Alright, good. I want us to do another transformation. Give me a second and plug this in. Alright, so they want us to do another transformation to P double prime. Let's see what it is again. Let's see what it is. Alright, so they wanted us to do a reflection now. So this second part wants us to do a reflection in the line y equals 0. Now you have to know that the line y equals 0 is actually the x-axis. Think about this question, you know. The line y equals 0 is actually the x-axis. You see, instead of saying x-axis, they said y equals 0. Could have been that they wanted a reflection line x equals 0. X equals 0 would be the y-axis. So you have to know the equation of the x-axis and the equation of the y-axis, right? This is the equation of the y-axis, y equals 0. And this is the equation of the x-axis. Alright, so you see that. So y equals 0 is the x-axis. They want us to reflect P, same P, and label P double prime. So same thing again. So we can do a translation on this and draw about the same shape. So we're reflecting it. So remember, you do reflection 1 point at a time. Let me take these out. Leave that P prime there. So you do your reflection. You're reflecting in this x-axis right here. I'm going to do it 1 point at a time. Image distance equals object distance. And these are purple for that. So this point first is 1, 2, 3, 4 to the mirror line. It goes 4 on the other side. 1, 2, 3, 4 to the other side. So that point is coming here. Let's take these out. Then this point over here, it is 1, 2, 3, 4, 5, 6 to the mirror line. It's going 6 on the other side. 1, 2, 3, 4, 5, 6 to here. And then naturally, this one across from it is the same distance. So it's coming the same distance down on the other side over here. So that point is coming here. And then this last point, that vertex up here, this one, it is 1, 2, 3, 4, 5, 6, 7 to the mirror line. It's gonna go 1, 2, 3, 4, 5, 6, 7 to the other side to here. So that's where the 4 points are on this reflection. Those are the 4 points. And you just draw the shape around them. Use a ruler and connect them. And let's almost label this one P double prime. It's a reflection in the x-axis, which is y equals 0. But okay with that? Just checking. Very good?
Yes, sir.
Alright, beautiful. So we finish those two. Here now it says we have to describe a single transformation. That's one transformation that maps P to Q. Let's look at it. P to Q. That's this one to this one. Now clearly that's an enlargement. Right? That's clearly an enlargement. An enlargement has two components that you must determine. It has a center of enlargement and it has a scale factor of enlargement. Remember, the scale factor can be positive, it can be negative, it can be a fraction value, it can be a whole number value. Now, the scale factor on this one is positive. I want to know it's positive. Because the image and the object point in the same direction. So this long point down here, for example, is pointing down. This corresponding piece is pointing down. So I already know that the K is a positive value. The K is also a value greater than 1. Because the thing got larger. So the K is also greater than 1. So we can check what the multiple is. And we can just use any dimension to check it. So for example, this piece across here is 2 units. The corresponding piece across here is how many? 1, 2, 3, 4, 5, 6 units across. From 2 to 6, you have to multiply by 3. So the scale factor is 3. Simple as that. Alright? If you wanted, you could use any other dimension. So for example, this single piece right to halfway here is 1 unit. The corresponding piece right to that diagonal piece is now 3 units. 1, 2, 3. Those two red lines correspond. From 1 to 3, you're multiplying by 3. So the scale factor greater than 1, the scale factor is 3. So you already know the scale factor by observation, by just looking. So you know the scale factor is 3. So you know that already. So let's write that down. Scale factor for this enlargement is 3. We need to find the center of the enlargement. The center of enlargement is on points joining, is on lines joining corresponding points. And the image and the object is going to be on the same side of the center. The enlargement is in this direction. So the center of the enlargement is somewhere over there. But this is like the image casting a shadow. So like the focal point is over here. So the center is over there. But how you find it? Simple. Join corresponding points. So for example, these 2 points are 2 easy points to join. And they are on this horizontal line, which is good. So the center is on this horizontal line. If I join these 2 points, extend it back, the center is on that horizontal line. Then I can choose 2 other points. Like for example, these 2. And join them. So use a ruler and I join them, these 2 points. And I extend it back. Right? Use your ruler and do it. Don't do it friendly like me. So join them and extend it back. So it looks as if this is the center of that enlargement. Now we can confirm it that is the center of the enlargement. Because remember, the scale factor also affects distance from the center. So for example, the distance to this point is 3 units. So if that is the center, then the distance to this corresponding point must be 9 units from the center. The distance to this point is 3 units. So the scale factor would triple that distance to 9 to bring it over to here. So let's check it. From here all the way over to here is how many units? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 9. So the distance to here, as we said, is 3 units to here. That distance has been tripled to 9 to this corresponding points. That confirms for me that this is in fact the center of my enlargement. Alright? Because it did not only triple the size, it also is tripling the distance from that center. So this is the center. What's the coordinates of this center? -10 up to 7. That's -10, 7 is the center of my enlargement. Now I have what I need to describe it. I have the scale factor and the center. So I can now describe that enlargement by stating the scale factor and the center. And remember, when the center is not the origin, you cannot use K00K. K00K is when the center is the origin. So you cannot go stating this matrix for this one. Alright? Because the center of this enlargement is not the origin. So we're going to just write it out. So this enlargement, Q, this maps to Q by an enlargement of scale factor K equals 3 and center, I can say about the point, So about the center, about the center, I can say the center is minus 10, 7. Because it's about the point, meaning it's about the center. But I'm using the word center in the description. So in describing an enlargement, you have to give the name enlargement. And enlargement has two components. There's a scale factor, which I have stated here, and there's a center, which I have stated here. You cannot just say it's an enlargement, and you cannot only just give the scale factor. You have to give the center as well. Enlargement has those two components that you must state if you're going to describe it fully. See, describe fully. When you describe a transformation fully, you give the name and they give the components of the transformation. Enlargement has two components, scale factor and center. You must state both of them. Then the next part wants us to do the transformation that maps P to R. P to R. Let's look at it. P to R. So we're talking about, let me take these off. Let's leave that center of the enlargement there. And scale factor is 3. So we're going, how do we go now from this one to this one? And this is the one that confused a lot of people. This transformation. Right? From this to this confused a lot of people. Now, I can know it's a rotation because this piece that was vertically pointing down this way is now pointing this way. So it has turned around by 90 degrees because what was vertical is now horizontal. So I know that's a 90 degrees rotation. But from vertical to horizontal, that's 90 degrees. And you can look at it that this turn around this way. Turn around, because we're going from this to this. You know? So like I can say that this point has turned up to be now pointing this way. So it's a 90 degrees anti-clockwise rotation. But the question is, where's the center? Right? So look at it, you know. That was pointing down. The arrow has rotated up and is now to be pointing now this way. So it's an anti-clockwise 90 degree rotation to get it from pointing down to be pointing to the right. Anti-clockwise 90 degrees. So we know it's a rotation 1. We know that it is anti-clockwise 2. And we know that it is 90 degrees. But rotation has 3 components. There's an angle, which you know is 90. There's a direction, which you know is anti-clockwise. But it also has a center of rotation. And if you don't state the center of rotation, you are not describing it fully. So we are going to have to determine where is the center of this rotation. Where is the center of this rotation? Now, this one got a lot of people because it was not obvious where the center of the rotation is. Most times it is obvious where the center of the rotation is. And we're gonna do other questions where it is obvious. But when it is not obvious where the center of the rotation is, we have to remember that we can construct to find the center of the rotation. The center of the rotation is on 2 perpendicular bisectors of lines joining corresponding points. So I've slowed down what I've said. You can listen back to the video and listen to it carefully. It is at the point of intersection of 2 perpendicular bisectors of the lines joining corresponding points. Let's see what I'm saying. So I'm going to choose 2 points. You have to basically know the corresponding points, you know. And we can know the corresponding points by labeling, right? So this point, if we call this point A, then this is corresponding point with B. A prime. And then now, if you come around the shape, then come around the shape to this point. So this point will be B, and this will be B prime. So those 2 are corresponding. This point up here will be C, this will be C prime, and this point down will be D, and this will be D prime. So those are your corresponding points, right? Now what is good is that these 2 corresponding points are on the same vertical line. I like to use points like those for your construction. So D and D prime are on the same vertical line. So that's two good points to use to get a perpendicular bisector. And then now we can use A and A prime, or we can use B and B prime. Alright? So I'm going to use D and D prime, and I'm going to use B and B prime. Right? They seem to be like out of the way. That's what I'm going to use. Right? So I'm going to be using these 2 points with our corresponding points, and I'm going to be using these 2 points which are also corresponding. So like I'm using this diagonal basically. Right? So these two correspond. Remember, these two correspond. So I'm going to find the perpendicular bisector of those two first. Put the other two in a different color, and these two correspond. Right? See, it is from that tip, it is that way, and from this tip, it is that way. So those two correspond. Alright, so let's go now. So let's do the two red ones first. Two red points first. I'm doing the perpendicular bisector of this line. So join those two corresponding points. I want the perpendicular bisector of this line. Let's construct the perpendicular bisector in purple. So the perpendicular bisector is the line that passes through the midpoint of this line, halfway mark on that line. Now that line is 1, 2, 3, 4, 5, 6, 7, 8 units long. So the halfway mark is 4. 1, 2, 3, 4. 1, 2, 3, 4. So the halfway mark for this is right here. 1, 2, 3, 4. 1, 2, 3, 4. Right. So that is the halfway mark. Perpendicular bisector. So this point bisects the line. Then the perpendicular to that vertical line is this horizontal line. So the center is somewhere on this line. This perpendicular bisector right now. I'm marking in purple. Let me use a blue now for the next perpendicular bisector between these 2 points. So I'm going to join them again. And I need to find the midpoint of this blue line now and the perpendicular to it. Now look at this blue line. We go from here to here. It is 1, 2, 3, 4, 5, 6 units down and 2 units back. 6 units down and minus 2 units. 6 down, 2 to the left. So the midpoint is going to be 3 down, 1 to the left from up the top. The midpoint is going to be 3 down, 1 to the left of that line. So it's 3 down, 1, 2, 3 down, and 1 to the left. So it means that right here to the marking in purple now is the midpoint of this line. You could also just put a ruler on it and get the halfway marking up. But I'm showing you could use the grids as well. So that point is the midpoint of that line. This point right now. And I need a perpendicular to this line. Now watch this now. You can also use gradient. Now you can use a protractor, you know. Alright? Put a protractor on it like so. And then get the perpendicular. Right? You could do that as well. Put the protractor on it and see what the perpendicular is. That way. Alright? So if you wanted to do that. And get the, in other words, put the protractor on it and then get the 90 degrees. Get out to the 90 degrees to get the perpendicular. I have all these instruments in the exam now to get the perpendicular. We could also use gradient. So for example, from this point to this point, what is the gradient? Rise 3, run 1. So the gradient of that blue line is 3 over 1. The perpendicular gradient to 3 over 1 is, flip this and change the sign, which is minus 1 over 3. So to get the perpendicular line from here, we could rise -1, run 3. Look, rise -1, run 3. Do it in red for you. Rise -1, which is come down 1, run 3. 1, 2, 3. So that's a point that is on this perpendicular from here, this point. So if I draw that perpendicular in purple, it will be coming through here. So right now, those two perpendicular, let me take these out. Right now, those two perpendicular purple lines. Those are the two perpendicular bisectors of the lines joining corresponding points. Oh, you want to get them. They meet at this point. So it means that this is the center of the rotation. This point right here I'm marking, is the center of the rotation. What is the coordinates? Negative 4, 2. The center of this rotation, not enlargement. Rotation, negative 4, 2. The center of that rotation. Negative 4, 2. Alright, let me take out this construction line and we can check if this in fact is the center of the rotation. Because I suppose to rotate this down to this 90 degrees and we can just kind of check it with corresponding points. So I'm going to take out these construction lines. Now remember what we did to find this point. Watch back the video and try it yourself. Use two perpendicular bisectors of line joining corresponding points. So we started out by saying these 2 points on that red line correspond to one another. We'll draw the line and we'll find the midpoint of the line and we'll do the perpendicular to it. And then we'll use two other corresponding points, which is these 2 points on the blue line. That's that line. We'll find the midpoint of it and then we'll do the perpendicular to it. So those two purple lines are your perpendicular bisectors. And they meet at this point. It means that that point is the center of that rotation. We know it is 90 degrees. But let me take all these construction lines now. Since we know the center, let me take these out. I want to measure from the center, that center point, if it is in fact the center of the rotation. So the blue points would have rotated from here. We can kind of check it, see if it makes sense. From this down to this. Yeah, rotate like this. And this angle is in fact 90 degrees. So that's a 90 degrees rotation. And again, that is what? Anti-clockwise. Right? You can see it. Right? And you can see that this length is the same as this length. You can see it. Right? If you want to kind of get the measure for the length, you can count it off. But this length can be counted off as 2 to the left and 4 up. So that's 2 by 4 length. Right? 2 by 4 in terms of a grid. See it here? 4 this way, 2 this way, or 4 by 2 length, which is the same length then. Right? Pythagoras still make it the same length. So it is true that this point rotates to this point 90 degrees clockwise, anti-clockwise. Right? And we can try the red points. Let's try the red. And any point you try it with, if it works for 2 points, then it will work for all the other points. Let's try the red. So this out to here has rotated down to here. So this is now of that. And you can see it. Those two red lines are at 90 degrees. And they're the same length again. What's the length of this line? We can break down that length into 1, 2, 3, 4. 1, 2, 3, 4. 4, 4. And so this length can break it down to 4, 4 as well. Look. 1, 2, 3, 4. 1, 2, 3, 4. So it means that those two lines have the same length. This length and this length is the same. Yes. So this line rotates around to this line. And so this point rotates around to this point 90 degrees clockwise. So you sure it is true for 2 points? Right? And you can do that. You can check for yourself on the exam just to make sure. So yes, that is the center of the rotation right here. So negative 4, 2. So we can now describe it. Right? It's an anti-clockwise, right? 90 degree rotation about this point. That's what it is. An anti-clockwise 90 degree rotation about that point. 3 marks for it. Right? That's what it is. So it's an anti-clockwise (90-degree) rotation about the point (-4, 2). And you cannot use the matrix for this one, guys, because the center is not the origin. You cannot use the 0, -1, 1, 0 anti-clockwise rotation for this. No, you can't use it. Because this one is for when the center of the rotation is the origin. You can't use that matrix. Alright? So, instead of saying anti-clockwise, as well. Remember, anti-clockwise rotation is positive, so it could have been positive 90 degrees rotation. You put a positive on it, they're supposed to give it a mask. They're supposed to understand that this positive means anti-clockwise. But safely, just write out the word anti-clockwise. But if they give you a question and they give you a positive 90 versus negative 90, remember the negative is clockwise and the positive is anti-clockwise. Anti-clockwise rotation is positive rotation. So we could have put positive 90 degrees as well. That's what anti-clockwise means. Positive 90 degrees rotation. What did we state in this? We gave the name of the transformation, which is rotation. And we gave the three components. What are the three components? The angle, which is 90 degrees, the direction, which is anti-clockwise, and most importantly, we also give the center of the rotation. Angle, direction, and center must be stated when you're describing a rotation. And that is it. What good at that? But okay? Alright, so this is one that's very, very important that you go and practice this one. Watch over the video and try this one yourself. The paper is in the group. You can print it out and try this one yourself for me, please. Try to construct to find the center of this rotation from this to this. Alright? Construct to find this center right here. Alright? Try it yourself because you might get another one like that in the exam. You want to be able to do it. Alright, so that is that for this paper. Alright, for that question. What is the other question on this paper to do? Let me see. Last question. Let me see if there's any transformation on it as well. Nah, no transformation on this one. That's just straight matrices. Alright, that's 2023. Let's go on and do 2022. 2022 January. Right here. January. All right, let's see. I don't like to set the classes to be too long, guys. So maybe an hour and a half. Don't want it to be too long. I want brother to just have a focus to the questions. Quick and fast, and then we move. Alright, so this is just this transformation question right here for this one. It says diagram shows triangle x prime, y prime, z prime. So giving us the image, you know. These are images they're giving us, you know. And x double prime, y double prime, z double prime. So these are images. They're not giving us the object yet. Drawn on a grid. Alright, so here now we're gonna have to work backwards to find what the object is. Let's see what they said. It says triangle XYZ is the image of triangle XY. Triangle X prime, Y prime, Z prime is the image of triangle XYZ after an enlargement of scale factor 2 with center 5, 1. Aha! And it wants us to draw that triangle. So to draw this triangle, we have to remember that the scale factor of 2 affects the size of the object and also distance from the center. So it's like we have to do a reverse enlargement or an inverse enlargement. Now the inverse enlargement would be an enlargement with the same center, but the scale factor would now be a half. Because if you double something first and you want to come back, you have gone for half it. So the center, the object is going to be half the distance from here of what this is, and also half the size. Let's look at it, see if we can understand what I'm saying. So first we need to put on the center point, 5, 1. Where's 5, 1? 5, 1 is right here. Right? Now remember, it's an enlargement of 2 that takes us from this to this, you know. Like from here to here, you know. So the image of this point is halfway here, so halfway along here. The object, I mean, from this point. Because the scale factor of 2 double that distance from where the original triangle. And see this side that was 2 is now 1 on the object. And this side is 1, 2, 3, 4 is now 2. So our image triangle is supposed to be half this size and half this size. But also half the distance away. So the best way to get the image is to measure these distances and half them. Let's do it one at a time. So let's say we're doing y to z first. What is the distance from y to z? This line, this distance, y to z. From the center to z. And we can do it by the grid. Instead of trying to use this actual distance, we can count the grid. The grid, this one, this, for example. Let's count that grid. So how many units up? And how many units across? About half that distance. 1, 2, 3, 4, 5, 6 units up. 1, 2, 3, 4, 5, 6 units across, easy. So it's coming 3, 3. Coming to 3, 3. 3, 3 from here. 3, 3 from here. Is where this point was. So it's 1, 2, 3, and coming across here 3. 1, 2, 3. So this is where this point was. So y is right here. Let's put that in purple for you. Y is right here. That's where y was. We can literally draw it now. Come just need to draw a triangle that is half that one, you know. Just draw a triangle that is half of this size. Just draw a triangle now that is half of this size, with the y prime being here. So this distance, this length is 2, so we're half in that. So this is where x was. And this length around here, so it's 4, and we're going to half that and put it at 2. So that's where this was, z. That's my triangle right there. Simple as that. Think you understand that construction, guy, what I did? I used 1 point and half the distance to see where the original was. Because the enlargement is a scale factor of 2 from this point. So if you're coming back to here, you're going to half the distance. And then now, I know the size is also half what it was. Because the scale factor is 2. So you see, this has been doubled to this, you know. So if you're going from the image back to here, you're going to have to take half. So this is the object that was mapped onto this from this point. But can you understand that? What good at that?
Yes, sir.
And you can check this. So for example, this distance out here was doubled. It was 1, 2, 3, 4 up 1. So it must go 8 up 2. See? 1, 2, 3, 4, 5, 6, 7, 8 up to 1, 2. Yes. So this point map onto this point by the enlargement. So that purple triangle is the object. So we take out these construction lines now. That is it. Put by the point. Put by the point. Let me put in one of them. Let's leave one of them in there, like maybe this one. Let's leave this one in there. I'll cut that in half to get this point, and I will draw about the shape. Half of this around it. And the enlargement was from this to this. So to come back from the image back to the object, you're going to have to take half the size and half the distance. Alright, this is the point 5, 1, center point 5, 1 of the enlargement. Everybody understand that. It's a good question to redo and practice. Alright, so we did that part of it. Draw the object. It says no, triangle x prime, y prime, z prime is now mapped onto the double prime. So now we're doing a transformation from this over to that. Alright? Going over there now. So going from this to this. The zoom point. That looks like a reflection line, you know. It says, oh, they tell you by a reflection line P. So the tail is a reflection. I want to state the equation of the line P. So the tail is a reflection, which you should know. It's a reflection. Why? How we know it's a reflection? Orientation is reversed. Look. X, Y, Z on this is clockwise. X, Y, Z on this is clockwise. X, Y, Z on this one is anti-clockwise, the other way. So know that we have a reflection in a line. And the mirror line is halfway between the points. So halfway, for example, between these 2 points. 1, 2, 3, 4, 5, 6. Halfway is 3. 1, 2, 3. So the mirror line is right here. This is the mirror line. That blue line is the mirror line. It's also halfway between these 2 points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That blue line is a mirror line. That blue line is a vertical line passing through 2 down here, so you can see it. A vertical line passing through 2 is x equals 2. That's the mirror line, x equals 2. And that's what I wanted. State the equation of the mirror line P. X equals 2 is that line. About to go to that. I like this question. It's a nice question to practice. Nice question to practice. You have to do a reverse transformation here, or inverse transformation, as I should say. The inverse of an enlargement of scale factor 2 is an enlargement of scale factor half from the same center. Alright? So just half the distance to get where the object is. Alright, that finishes that question. Let's look if there's any in section 2. There's 1 o'clock already, about half an hour more. Started about 11 o'clock. Let's see if there's any in section 2 here. Apparently not. Let's see down here. That's matrices. Alright, this is a transformation right here. It says a transformation T represented by this matrix. You should know this matrix on side. It maps this onto this. If you notice the coordinates are reversed. 2, 5 becomes 5, 2. More things you know, the better. You have to figure out stuff when you can know. Describe the transformation fully. This is the matrix for reflecting line y equals x. Just know it. And you have to figure it out. It takes time to figure out stuff. Know what you can know. And I told you the matrix that you must know. See, this is one of them. This is a reflection line y equals x. A reflection in the line y equals x. That's what this matrix is. I could know from the points as well. Or from function, remember that inverse function reverses the coordinates, right? Because domain becomes range and range becomes domain. And the relationship between a function and its inverse is the same thing that we have here, a reflection in the line y equals x. So anyway you want to look at it, that's what it is, a reflection line y equals x. A very easy question. 2 marks for just knowing this matrix. I know that's what it is. Alright, so that is it. Everybody good? Everybody good with that? Students?
Yes, sir.
Alright,
Yes, sir.
2021. January 2021. Alright, let's see now. This is 2021 transformation. 2021. Alright, here we go. Enlargement of that A. Remember this question. It says the letter A and the 0.66 are shown. So this is 0.66 and that's the letter A. It says, on the diagram, draw accurately each of the following transformation. An enlargement of letter A by a scale factor 2 from the 0.66. So that is all. Remember now that enlargement of scale factor 2 also affects distance from the center point. So you're not going to go only draw as a that is twice as large. It has to be twice the distance from here as well. That's what this is about. Alright? So the important thing that we have to go now and enlarge this by making the points go twice the distance from here. So let's start with this point. What's this distance? So I have to double that distance. That's just 2 grid across 2 grid. So this one kind of easy. You double the distance by going across 2 more grids. So this point is coming to here. Let's put the image point in purple. Right here. So this point is coming to here. Okay, double that distance. But understand that we have doubled this distance. The scale factor is 2. Alright? And then this point, we can draw A that is now twice its size from this point, you know. We can do that now, you know. Just draw A now that is twice its size from this point. So for example, this length is doubled to there. So draw a thing double that length, like so. So this length is across 2 grid now. is across one grid. Alright, let's look at it this way. It is 1 across, 2 down to get this side. So we're going to go 2 across, 4 down, 2 across, 4 down, 1, 2, 3, 4. So this point is coming here, right there, sir. And then this distance across here is 2. So on the enlarged one is 4. 1, 2, 3, 4 to here. That's the outline of your A. Right now. And then this now is 1 unit from the top, or almost a unit from the top. This horizontal line, or this cross piece. That halfway, you know, a little bit above. Almost at 1 unit. So this kind of going almost 2 units, but I have to go above. So for 2 units, it's about here. And even this little gap has to be doubled. This little gap in between here also has to be doubled by a scale factor of 2. So it will be maybe down here. That will be an image A. No, wrong page, right here. 2 units, 1, 2 down, almost 2 units down. That's the image A right there. That's it. We could have also done the construction of these points by doubling the distance. Continue to double the distance from the center point here. So let's do it that way again and show you. Right? Multiple ways to do these things. So I'm going to use the distance from the center point. So this distance to this point is doubled. How can I measure that distance to this point? This is 1, 2, 3, 4 down, 1 across. So we double that distance, it's going to be 8 down, 2 across. 8 down, 2 across. So you go 1, 2, 3, 4, 5, 6, 7, 8 down, 2 across. 1, 2 to here. Okay, so this distance is doubled. This length has been doubled to there. Alright. And then now you can do over here as well. The distance down here, this point, is doubled. But you see, we never have to do that now because we know that this length is doubled. That length is 2, gonna double to 4 to here. So we don't want to do it hard, do it easy. So that point is coming down to here. Right, and then as I said, this height is doubled, but the gap inside is also doubled. So don't put on this line, you know. Oh man. Don't put on this line, you know. Don't put on this line. Because it is not on this half mark line. It's above it. So don't put it there. So you have to double look a gap. Look a gap that is inside here. Between this line and this halfway line, that gap also has to be doubled. Right? So join these two. Join these two. Come to about the halfway mark where you have a gap between it. That has to be doubled. So I'll put it about here. But I'm comfortable with that. That's the image. Are you good at that? Everything is doubled. So distance from here to here is doubled. Distance from here to here is doubled. Distance from here to this vertex is doubled. To this vertex is doubled. That's the image of the enlargement. I wonder if everybody okay. Could have done this. But alright?
Yes, sir.
Alright, the next part wants us to do a translation. Translation always very easy. Negative 3, 2. So negative 3, 2. The negative 3 means 3 to the left. Start at a point. It's 3 to the left. 3 to the left. This 2 means 2 up. To here. So we're moving each point on triangle A, 3 to the left, 2 up. We can just move 1 point first. So we can just move this point alone. 3 to the left, 2 up. 1, 2, 3 to the left, 2 up. 1, 2. So this point is coming here. Let's put down in blue. and it was draw about the same shape around that one point. I can do 2 up first. 2 up first, and then 3 to the left. Same thing. Alright, I'll draw about the same shape around that one point now. So I'm going to draw this diagonal piece, which is 1 across, 2 down. 1 across, 2 down, please put this here. And this piece is 1 to the left, 2 down. It's going to here. Then this halfway mark again, that crosses a little bit above that halfway mark. That's the image of the translation, which is, what is it? 3 to the left, 2 up. So it's 3 to the left and 2 up. That is it. That finishes that question? Yes, it finishes. That's it. Easy question, easy. But okay with that? But good?
Yes, sir.
Alright. Let's see if there's another question on the back. Let me see, let's see. No, this is not enlargement, it's just 3 matrices. That's not enlargement. This one is enlargement. It's the same matrix again the following year now, guys. Same matrix. The paper that we just did, which was 2022, they give out the same matrix. That's the y-axis reflection, y equals x reflection again. Coordinates are switched around. Right? That's a reflection line y equals x. See? It says, easy question, listen, it says, the right angle triangle M, right angle triangle M has these vertices. These are the vertices, right? When M is transformed by the matrix, this, which is a y equals x reflection matrix, y equals x reflection. And that maps a point xy onto yx. That's what it does. Reverses the coordinates. Alright, I'm gonna use AB then. It takes a point AB and turns it into BA. Moves it to BA. This question says find the coordinates of M prime, which is the image after you reflect this. So doing the image of these points. So it's easy. X prime is going to be 1, 1, so it's the same. Because if you flip around 1, 1, stays 1, 1. Y prime is going to be, flip around, is going to get 1, 3. And Z prime switches around, is going to get 4, 3. And this is my explanation. Let me move this down. This is my explanation for it. That's what it is. I've done it. I've said it is a y equals x reflection. Reflection line y equals x. And what that does is reverses coordinates. So I must reverse coordinates of these points that they gave me. That's the answer right there. Coordinates of the vertices of M, triangle M prime, the image of M. These are the points on the triangle M. So the points on triangle M prime are these. That's it. Are you okay with that? Are you good?
Yes, sir.
If you don't remember what a matrix does to a point, you can work it out, look. You look a random point. And so, okay, 0, 1, 1, 0. And multiply by a general point xy. And work out what it does. Right? Work out what it does. It will be 0 times x is 0, 1 times y is y. So the first value is y. It will be 1 times x is x, and 0 times y is 0, so the second value is x. That's what this matrix does. Reverses the coordinates. So it means that x, y are mapped by 0, 1, 1, 0, which is a y-axis reflection, onto the point yx. So in other words, the coordinates are switched around. So you could work it out. If you remember the matrices, then now which question you're doing, can always multiply a matrix by a point, a general point xy, and see how the values change. Then you just apply that exact same change to all the points, and you're done. Alright, but this one is finished. This one is finished. Let me see which other paper I gave it. I also gave you where is it? Alright, so that's what 2021. And I give it 2020. Okay, I give you something on 2020 as well. Something on 2020. 2020. This one. Alright. Question 3C and question 10. Alright, this is 3C. Alright. So this one gives us this paper. This is January 2020. It says the quadrilateral PQRS and its image P prime, Q prime, RS are shown on the grid. It's clearly an enlargement. It's a positive scale factor, right? And the scale factor is a value greater than 1 because the thing get bigger, right? What's about that scale factor? Easy. This side here so is 1 unit. That's grown to 3 units. That's a multiple of 3. So K equals 3 already. All we need now is the center of the enlargement. How do we find center of the enlargement? It join corresponding points. So for example, P prime and P. Easy points to use first. So you know the center is on this line. And then Q prime and Q. So join these two. Use 0 and extend it back. It's like here is the center. Let's double check it. Remember, scale factor also affects distance, right? So distance to P right here, so right now it's 3 units. So the scale factor is 3, supposed to move this to 9 units. Let's see. Let's see if it's 9 units. Out to here. 1, 2, 3, 4, 5, 6. So that's not right. So this is not the center. Right? That's not the center. That's not right. So it looks like it is actually down here. I'm supposed to come. So I do have a ruler now, guys. So you have to bear with me, right? So if I ruler, just join these 2 points and extend it, you'll find it easier. Looks like it is right here. So this distance is 2 units right now. If I apply a scale factor of 3, you're going to triple the 2 to make 6. So it's going to be 6 units out to P prime, this distance. It's going to be 6 units. 1, 2, 3, 4, 5, 6. Good. So this is the center of the enlargement for you. What is that? Negative 4, 1. This point is negative 4 up 1. So the scale factor is an enlargement, so scale factor 3 about the point negative 4. Let's write that. Alright, so that's the enlargement. They don't ask us right. The first part says write down the coordinate, write down the name of a quadrilateral. That's a trapezium. It has 1 pair of parallel sides. A trapezium. I know don't they say it, but that's the name of it, a trapezium. It says PQRS is mapped onto P prime, Q prime, R prime by an enlargement. So get helping you of scale factor K. We know the K is 3. About the center point C, which is AB. Using the diagram above to determine AB and K. So the K is 2. The enlargement is of scale factor 3. So the K equals 3, not 2, 3. And the center point AB is actually this point that we just worked out here, negative 4, 1. Which means that A is equal to negative 4 and the B is equal to 1. That's the answer. K is the clear factor of 3. These are the coordinates of the center point. Alright, that finishes that question. But good? But okay with that? So must start to say that this topic is really very easy, guys. Really very easy. But okay? Okay with that?
Yes, sir.
Alright, let's look at the number 10 question now. Number 10. Alright, here we go. What is the question says? This question says transformation M 0P minus 1 0 maps R to R prime as shown in the diagram, right? So it maps this point to this point. And they're showing this now like as a center. It's like a center rotation, you know. Alright? That's what it says. It says determine the values of P and Q. So you have to know the transformation. So this to this. Like a rotation this way. Anti-clockwise 90-degree rotation from this center point.
Yeah.
Distant and distant is the same. Mute the mic, please. Mute the mic. Right? There's the anti-clockwise 90-degree rotation about the origin. What it is. So it's anti-clockwise 90 degrees rotation about origin. Negative 1 is here, 1 is here, 0, 0. Know the matrix and everything get easy. Right? So what did they give us? They give us P up here, so, and Q down here, so. We're saying that this matrix is 0 and negative 1, 1, 0. So based on that, the P is equal to negative 1 and the Q is equal to 1. P equals negative 1, Q equals 1. So let's say the matrix is 0, minus 1, 1, 0. So this is the P and this is the Q. So P equals negative 1, Q equals 1. That's the matrix for anti-clockwise. And so describe it fully. Right? Now, another way we could have worked it out is to actually calculate. So let's calculate it, because I guess maybe that's not the only way we could have gone. That's not the only way we could have gone from here to here, right? I'll be by observation, because I think if you're reflecting this line, but let's do it by calculation. Let's do it by calculation and show you. Maybe that's what they wanted us to do. Right, rather than just do it by observation. Let's do it by calculation and show you. Let's do it by calculation. So we're going to use the points. R is a point 2, negative 5. R prime is the point 5, 2. Alright, so what this is basically saying is that the point R 2, negative 5 was mapped by the matrix 0P Q 0 to the point R, which is 5, 2. R prime, which is 5, 2. It means that when you apply this matrix to this point, the answer is that point. That's what it means, you know. So let's set up like an equation of equality of matrices. So 0P Q 0, rather than use the observation method, times 2, negative 5 is equal to 5, 2. So set up like that. Means then, let's go for the red. This row times this column is equal to 5. So that means, you know, that row times that column is equal to 5. Alright, so 0 times 2, let's write it out. 0 times 2 plus P times negative 5, P times negative 5. That's all equal to 5. That is minus p equals 5. No, sorry, minus 5p equals 5. Minus 5p equals 5. Divided by the minus 5, we get p equals negative 1. Alright? And then the second part is that this row times this column equals 2. So then it becomes q times 2, which is 2q. And 0 times negative 5. Let's write out q times 2. So that would do. This time is q times 2. And then 0 times negative 5 is equal to this 2 down here. This is 2q equals 2. Divided by this 2, where q equals 1. Same answer as we have. So we do it by calculation. They don't want us to describe it. To describe, we have to know the matrix fully. We have to know the transformation. So transformation matrix becomes 0, minus 1, 1, 0. That's an anti-clockwise 90 degree rotation matrix about the origin. Anti-clockwise 90 degree rotation. 90 degrees about the origin. That's it. It's an anti-clockwise 90 degree rotation about the origin. So it's a rotation, it must have 3 components. So give the name rotation and 3 components: angle, direction, and center. So that description is good. Angle, direction, and center. Anything else to do with this question? Don't know. That is it. But alright with that? Okay with that, guys? Alright, it's just about 1:30. I think I'm going to stop it here.
Yes, sir.
I think I'm just going to stop it here. I don't know if I'm going to start the classes online or too long. So I think I'm going to stop it here. Alright, we have one more question. I'll give you one more question. Let's do that one more question. I'll give you a paper question for 2018. So let's do that question. I never call it a day. 2018. Where are you? 2018 right here. Alright. So this one is number 6. This is a full question. Number 6. Number 6 on this paper. Alright, good. This question says, diagram below shows triangle PQR. State the coordinates of the point R right here. That is 0, 3. See? Halfway between 2 and 4 is 3. On the y-axis, x value is 0. So R is a point 0, 3. That's an easy. Next part. Draw, on the diagram, draw P prime, Q prime, R prime, the image of triangle PQR after reflection line y equals 1. So reflecting line y equals 1. Y equals 1 is a horizontal line passing through 1. That's this line. Y equals 1. Reflecting the line y equals 1. It's one mirror line. And image distance equals object distance. Let's draw the image in purple. So this point is 1 to the line, go 1 on the other side to here. So that's P prime. This one is 2 units to the line, it goes 2 on the other side. 2 on the other side to here. This is R prime right here. And then this one is 1, 2, 3, 4 to the line. We're going to go 4 on the other side. 1, 2, 3, 4 to here. That's Q prime. take these out now. That's the image. That first reflection. That's it. After reflection line, y equals 1. Alright, next part says we're to now do the double prime one, a reflection of the prime one in line x equals 0. Now again, line x equals 0 is the y-axis. You have to know that. So reflecting now in the y-axis. So reflecting this in the y-axis. So our second mirror line now is this. What are we doing, guys? We are doing compound transformations right here now. So reflecting the line y equals 1, and we're now reflecting the line x equals 0. That's the line x equals 0. Move this over. So doing two reflections. Alright? So let's draw that one in. Let's draw that one in red. So the second reflection now is reflect this point on the mirror line, so invariant point stays where it is. So this same point is r double prime is the same point. So this point is r prime and r double prime. So I'm label the r prime on the left side and the r double prime on the right. Let's label this one over here. So it is r prime. It is also r double prime. Alright, then now this point, it is 2 to the mirror line, 2 on the other side to here. So this point is coming over here. Let's put that in red as well. Red right here. So that's where Q double prime will go. And this one up here, same thing. 2 to the mirror line, 2 on the other side. So it's coming here. And that's where C double prime would be. And then join them. And that is it. So what did we do, guys? With the two reflections over intersecting lines. So right away, you know, you see from this to this is a rotation, you know. The rotation angle is 180 degrees, you know. And the center of the rotation is right here, you know, where the two lines meet, you know. So you should already know that. Let's put that part in purple or in green, some other color. Let's see. Let's put that part in green or something. It's green. Right. So from this one to this one is a rotation. Two reflections equal one rotation. And between these two mirror lines right here, so it's 90 degrees. And put it down in blue. The 90 degree angle between these two mirror lines right here. So the rotation angle there is 180 degrees. I can say direction is clockwise based on what we got. That's 180 degrees. The rotation angle is twice angle between the two lines. And then the center of the rotation is right here, where the two lines meet, which is the point 0, 1. Center of the rotation is 0, 1. So I tell you, you can know the answer for a question before you even do it. You should know that already. So it's a clockwise rotation, 180 degrees about the point 0, 1. I take it from the first triangle to the last triangle. If you ask for a single transformation, that's what they ask us for. Alright, down here now say, describe fully a single transformation that maps the double prime onto the original one. Oh, so they want us to reverse it. Reversing it. So look at it now. From this one to this one. We just said from this one to this one is a 180 degrees clockwise rotation about the point 0, 1. But the question is asking us to go the other way. Let's put it in blue. It's asking us to go the other way. So we're doing the inverse of that green. The inverse of a rotation is a rotation in the opposite direction. Same angle, same center. Simple as that. So this, what we want is this in blue. I'm going to write over here. That's what the question wants. They want us to go from the image back to the object. So they want us to do reverse this transformation. They want us to go this way instead. This way. From the red back to the black. So that is it. We're using the concept of a compound transformation same way, but just that we're going in the opposite direction. If everybody can understand this, that's a nice question to redo, you know. So what they want is an anti-clockwise and anti-clockwise. That's what they want. This is what we're describing now for this transformation that they want in blue. And anti-clockwise. (180 degrees rotation about a rotation must have a center about the point where the two lines meet, which is 0, 1 on the y-axis. That's it. But okay with that? But good at that?
Yes, sir.
It's a nice question to finish off with. I don't like this. It says PQR undergoes an enlargement of scale factor 2. Calculate the image of that. Calculate the area of the image. Remember, area of image of an enlargement is k squared times the area of the object. And I want the area of the image. K squared, k is 2. So we need to work out what the area of that object is. That's the area of triangle PQR is the area of the object in this question. Alright? So the area of PQR, this triangle, what will be the area of that triangle there? So easy. This is the base and this is the height. Alright? So the area of the object will be half this, which is 3. Half 3. Half of 3 times this perpendicular height of 2 units. This half cancels this 2, so it becomes 3 units squared. Is the area of that triangle, 3 units squared. Come back down here, so now. Just worked out that the area of the object is 3 units squared of the top. So this area of the image that I want becomes 2 squared, because the area of scale factor is 2, times 3 is 3 over here. So this is 4. It becomes 12 units squared. This formula this thing must be remembered. This is a must know right here. If you look at the must know sheet, you'll see it. One of the must know items. Once you get into transformation area, you have to remember this. Area of image of a transformation is k squared times the area of the object. It's a nice question to remember. But that is it. That is it for today, guys. How long ago? About an hour and a half, which is good. So I'd like you to redo these questions. Those who are not here, you have to do them as well. But that is it for today, guys. See you in class tomorrow, starting a new topic tomorrow, starting vectors tomorrow. Bye, everybody. I'm going to send the video to the group right after. Make sure you read the questions. Alright, bye. I'm going to end it now.